are probably one of the most common things, and they're really kind of what most programs are built around. Because essentially, a function is just a reusable piece of code. If you really think about a lot of the things that we've done so far, right? We've basically been creating functions. We're saying, hey, I want to write these set of instructions, and I want to be able to give you a value, and I want you to give me back another value. And really, kind of, if you think about kind of, if you can take a step back and think about the repetition, the repetitive nature of programming, in general, functions kind of are the foundation for that, right? If a function is a recipe, well, I can actually copy that recipe and use that recipe as many times as I want without exhausting the underlying recipe. And so, same as a function. Once I built a function, I can actually use a function as many times as I want without exhausting it or without kind of using it up, if you will. So here on the right hand side, when we look at functions, this here on the right hand side, this is a function. And if you notice, we create a function by using the function keyword. In this example, we see that the word function is in red, which tells us that it's a reserved keyword, i.e. it's an actual part of the JavaScript language. So so you can't have a variable called function, it means something different. After the word function, we're then going to create the name of our function. In this case, our function's name is just bake cookies. Afterwards, we have these set of parentheses. And these two parentheses, we're going to have some things in these parentheses. Now, these parentheses could be empty as well, or they could have things in them. And essentially what these parentheses set are, these parentheses basically set the variables that we're going to input into our function. So if we take a look here in our function bake cookies, one of the things that we don't actually know is what flavor we want to bake the cookies, or what kind of cookies we want to bake, so the flavor of the cookies. Nor do we know the number of servings in the cookies. And so those are two pieces of information that are very important to us, but that can also change every time we run the function, right? Because on the first time I bake the cookies, I go on chocolate cookies. The second time I bake it, I go on vanilla cookies. And so because of that, all of the independent variables in the function, so all of the things in the function that are able to be changed, they're the pieces of information that we actually need to tell our function beforehand. Like before we run our function, we're essentially having our functions take a look and say, look, here are the things that you need to know before you can start operating or before you can actually run. Okay, and so in between the parentheses, here we have two things, right? And I say two is because we have two variables and they're separated by a comma. And so every time we see a comma here, it just means that's the end of one variable and the beginning of the next variable. So here, the first variable that whenever we run this function that we need to know is the variable flavor. And the second variable that we need to know is the variable servings. Okay, and these two are very important because what we've done is we've created a condition that essentially says this function cannot run unless we know the flavor, and unless we know the servings as well. After we name the function and after we designate what information needs to go into the function, we then have our open and close curly braces, and that basically is our code block. That's the part of the function that runs over and over and over again. If we look at line 2 here, what are we actually doing? Well, on line 2, we're creating a variable called flavoring using the var keyword, and we're setting the value of that equal to flavor. Now, where do we determine what flavor was? If we look on line 1, right, at our inputs, we'll see that, if you remember, flavor was the first input that we said we needed to collect before we can run our function. In this case, we call these things parameters, or parameters is a word for the things that are passed into the function, or the information that's given into the function, so that we can run it later on. Okay, so the first thing we do on line 2 is we create a variable called flavoring, and we give it the value of the flavor, or the first input. The next thing we do is we create a variable called batter, and we set it equal to flavoring plus servings. Now, the variable flavorings we made on line 2, right? We just created a variable there. And then on line 3, and then for servings, if we take a look at the blue text up top, that's the second input that our function collected. So right now, all we're really saying is, hey, for this variable batter, it's equal to the value of the variable flavoring plus the value of the variable servings. Next, we then invoke a function called preheat oven, and then we invoke a function called add cookies to sheet. Okay, invoking a function is actually very critical for us to understand. One of the more common mistakes that people make is when they first start off, they think that making a function is the same thing as running a function. When in reality, it's not, right? When we make a function, all we're saying is this variable now exists, right? This function now exists. On this top block of text here, under the function bake cookies, all we've done so far is we said this function bake cookies now exists. We have not actually run the function yet. If we go one line down now, or one block down now into the bake cookies, notice how there's an open parentheses after bake cookies and then a closed parentheses at the near the end of the line. Only and only when you see a function with the open and closed parentheses after it does that mean we're actually running or we're actually invoking the function. And that's a super important designation for us to be aware of, because running a function means let's execute all of the code in the function. If we don't have the open and closed parentheses after it, it doesn't mean we're running the function at all. It just means we're saying, hey, look, here's a function. We're not doing anything with it. It's the same thing as buying a car versus driving a car, right? Up top, all we've done is saying, hey, look, we bought a car. On the lines on the bottom, that's where we're actually saying, hey, let's use the car. Let's actually drive the car. Similarly, on the first block, all we've done is we've created a function. But in the examples on the bottom, when we had the open and closed parentheses after the bake cookies variable, that's the only way that that's the only way that we're able to actually invoke or run the functions. The last thing to notice is that in the bake cookies function, notice the types of information that we're passing in. In the first time we run it in the middle block, we're passing in the string chocolate as our first argument, and then we're saying we're having a comma, and then we have the number 5, which is the second piece of information that we're passing in. Well, here we're passing in 2 pieces of information, and notice how it correlates very nicely to, if we jump up top to the bake cookies function, it correlates very nicely to our function, which is expecting 2 pieces of information. And so the way JavaScript does is it does it in sequential order. So in this case, the first input that bake cookies expects is the variable is a variable flavor. That's, or whatever is the first value being passed into the bake cookies function when we run it, that corresponds to the first input that the function is expecting. So here, because the function is expecting the first input to be flavor, then it will, in the example here, it uses chocolate as the flavor. Similarly, the second input that the bake cookies function is expecting is the variable servings. So then, therefore, when I invoke bake cookies and I pass in 5 as my second argument or my second piece of information, the bake cookies function says, now the value for my servings parameter is going to be the number 5. But that information can change every time we run the function, right? Because if we look at the last block of code on this page here, we are invoking bake cookies again. Remember, that's the whole point of a function. It's a reusable piece of code. We can bake as many cookies as we want. We can run this function as many times as we want. Except now our input information is different. The first the first input that we give it is actually the string vanilla. Well, the first piece of information that we give it is going to correspond to the first piece of input that the bake cookies function is expecting, which again is flavor. So therefore, bake cookie says, okay, my flavor value is going to equal the string vanilla, and then my second argument is going to be the number 10, and so the bake cookies function is going to say, great, now my servings variable is going to equal 10. And so now what we've done is we've created a reusable piece of code, but every time we run it, we can actually pass it in different information. And so every time we bake cookies, we could be baking different types of cookies as well as different servings. And so that's why functions are very powerful, is because they can actually automate most of what you're trying to do, but they can also give you enough flexibility to say, hey, every time you run it, I know you want to do these few things differently. Give me the new information, and I'll run it for you with that new information. Any questions so far? Everyone good? Everyone good? Sorry, I couldn't hear folks.
Okay.
Oh, sorry, I can. Oh, you're all okay. Cool. Pam, Eric, everything good?
Yeah, I'm good too. Thank you.
Okay, cool.
Okay. Can you hear me? I have a question.
Yeah, sorry, I can't tell who's talking, but I can hear you.
This is Holly.
Oh,
Okay,
hey,
sorry.
hey, Holly.
My-
Oh, I think that's you, Holly, right? Or is that me? I think it's you.
I'm going to try it again. Is it me?
Okay, I can hear you good now.
Okay.
So talk while we're
All
still
right.
clear.
My question is there a place to define what data types your parameters are supposed to be?
Yeah, excellent question. In JavaScript, no. In other languages, you do have to say, "Hey, my flavor variable, I expect it to be a number or a string." In JavaScript, no. You can just say, "This is going to be a variable, and whatever comes comes." It's a really great question, right? Because when I invoke the bake cookies function, I could easily make my first argument a number, and that's totally fair. JavaScript is just going to say take flavor and make it equal. Sorry, there's a lot of background noise. Let me see if I can figure out whose it is. I'm going to mute everyone who's not talking. Okay, there we go. Okay, all right, everyone's muted. Cool. Yeah, sorry. So that was a really good question, Holly. So yes, in other languages, you have to specify what argument you're expecting to get, or what the type of variable is. In JavaScript, you don't. You just need to say I'm expecting a variable, and JavaScript will use whatever you pass into it.
Just to expand upon that a little bit, that fact about JavaScript can get you in trouble because there is something called implicit coercion, where your data types can change because JavaScript makes an assumption, which may not be the correct assumption. So that could be a source of bugs. So it's worth keeping an eye out for something like that.
Well, I would imagine that it could come into problems if you have some sort of calculations or something and you're getting a string instead of a number.
Oh, absolutely. And there are ways like you can run your environment in like strict mode, which will help out a little bit. And you can also implement in certain libraries like React, you can implement like prop types where you can designate kind of what you expect your properties that you're passing into different components to be. And you can take it even more extreme and like implement things like TypeScript, which is essentially a strongly typed version of JavaScript in a way that would actually take care of a lot of those issues. So yes, it is a problem. That's what makes JavaScript fun, but there are things you can do to kind of avoid those issues.
Yeah, and kind of one best practice in general, we see a lot of code in the wild is whenever a function takes in information, usually before they try to do anything too complex with it, you'll see a bunch of code checking the inputs just to make sure that it meets the criteria that the function is expecting, right? So like a very kind of well-manicured code will actually say, if I'm going to do a mathematical calculation, I'm just going to do a quick check on my inputs to make sure that they're real numbers before I start doing all the math afterwards. In reality, for like simpler apps or kind of less precise apps, sometimes people don't do it, but it is kind of Tom said, like there are ways to kind of really make sure that you enforce the types of your inputs for your functions. Cool.
We actually learned in Dirty Way yesterday, right? Simple conditional statement can help just by checking a condition, whether or not it's a number or a string before actually using it. So you already have the tools to actually, protect yourself against, types of coercion.
Yep. Cool. So here, just to kind of move on, here we're taking a look at another example of a function. Sorry for the green text. We're still creating a function because we still see the function keyword as the very first thing. Here, the name of our function is add 4 numbers, all in one word. Remember, functions are just like any other values in JavaScript. When we make a variable for the function, no spaces in the function, has to be one continuous word. Okay. Here, when we look at add 4 numbers, in the parentheses following add 4 numbers, here we have how many inputs? Well, we have 4 inputs because we have 4 values separated by 3 commas, right? And the first value is going to be called num1, second value is going to be called num2, num3, and num4, and so on. And then when we look into our actual code block in the curly braces, we see that we're creating a variable called sum, and we're setting it equal to num1 plus num2 plus num3 plus num4. And then afterwards, we come back to this thing called return sum. Return is actually a very important idea, and unfortunately, we don't really do it the proper amount of justice in this particular class. In this case, just know that what return means is I'm going to give a value back from the function. It's also a very important thing to note because return, once a function hits the return statement, it's not going to run anything else after it, and the function ends then there. And so for that reason, most of the times when you see a return statement, it's usually near the very end of the function. Okay, so return statements give a value back from the function. That's the first thing. And the second thing does is it actually ends the function then there. So don't bother putting any code after return statement. JavaScript won't even run it because it'll just end the function at that point. One point of confusion for a lot of folks is they get confused between return versus console log. And so for our intents and purposes, when you're actually doing kind of problems that required computing values and using them in other areas, console logs are not useful to a computer. For the most part, what all console logs are is they're printing out messages to the screen for the human user to take a look at. They don't have any functionality in terms of saying, hey, let me actually take this value and pass it somewhere else. Return is what allows us to take the output of one function and use it somewhere else. Okay, and so this actually on the very last line is actually a great example. Here I have I've created a variable called mySum, and it's equal to me to the add 4 numbers invoking that function. And I know I'm invoking it because after add 4 numbers, I see the open and the close parentheses. Now I'm passing in 4 numbers into the add 4 numbers function, and in this case, because the order follows the order of the parameters follows the order of the inputs, num1 is equal to 1, num2 is equal to 2, and so on and so forth. I'm going to add up those 4 numbers, 1 plus 2 plus 3 plus 4, and I'm going to get back 10. And then here, add 4 numbers is going to return 10. What does return mean? Return means now, on the very last line of code, after add 4 numbers returns 10, the right-hand side of the equal sign is now replaced by the number 10. And so that last line of code basically reads var mySum is equal to 10, which means we're assigning the value of 10 to mySum. If I don't return the 10 from the add 4 from the 4 numbers function, and I just print out a console log, well, then by default, my function is going to return undefined. Okay, and so that's the last thing you should know about return statements is that every function in JavaScript has to return something. And if you don't tell it explicitly what to return, then by default, it's going to return undefined. And so if I don't return 10 here, I'm actually going to return undefined, and my last line of code becomes var mySum equals undefined. So if you're trying to use a value coming back from your function, always make sure that you explicitly define what that value is.
So if you invoke a function but you don't have enough parameters, will then it return undefined?
No. So by default, if it expects a parameter and you don't give it to it, if you don't give that value, then JavaScript will assume the value of that parameter in the function is undefined, and it will try doing whatever you gave it, and it will try using undefined. It may work, it may not work. Most cases, it will probably not work, and it will probably throw you some kind of error along the way. On the other hand, if you give it extra parameters, so let's say I pass it in 1, 2, 3, 4, 5, 6, well, the JavaScript will just ignore the 5 and the 6, and it'll just say, I only expected 4 things. So if you give me 6 things, I'm just going to use the first 4 that you gave me. Cool. Any other questions? Okay. The next thing we'll talk about is an object. And an object is something that you might have seen already. It's another data type. The technical definition for an object in JavaScript is an unordered collection of key value pairs. Saying an object is a collection of key value pairs is somewhat confusing. One analogy that works out very, very well, and if you've done Python before, then this should sound very familiar. A common analogy for an object is that it's like a dictionary. So in the same way that an object is a collection of key value pairs, it's like saying a dictionary is a collection of words and their definitions, right? Every word has a definition, and so we can think of that as the word definition pair. That's kind of exactly how a key value pair works. Every key has a value that matches to it, and together those two things form a key value pair. And so an object is just a lot of key value pairs together, in the same way that a dictionary is just a lot of words and their definitions together. The way to create an object is with just the curly brace. And so here on line 5, I've created a variable called myObject, and the value of it is going to be an object. And I use a curly brace. A key value pair is basically created with two pieces of syntax. The first one is a colon, and everything to the left of the colon is going to be the key, and everything to the right of the colon is going to be the value. And we separate each key value pair with a comma. And so in this case here, on line 6, that's our first key value pair. We have a colon, which says that everything to the left of the colon is a key. So in this case, a key is called key 1. And then to the right of the colon, until we reach the comma, that's what the value is. And so the value is value 1. And so the key value pair is key 1 matched to value 1. The comma says, okay, we're done with this key value pair. Let's move on to the next key value pair. And so the next key value pair works in the same exact way. We have a colon, so everything to the left of the colon is going to be the key, which in this case is word 1. And then everything to the right of the colon is going to be the value, so definition 1. And so value 1 is the value for key 1, and then definition 1 is the value for word 1. And taken together, all these things form an object. The way we access a given value in a key in an object is actually very similar to the way we do it for arrays. But if you're not familiar with it, essentially we use something called bracket notation. And what bracket notation does is we still use myObject as to say, hey, this is the object we're looking at, and we basically pass in whatever key we're trying to find. We pass it in as a string into the brackets. And so here, when I console log out myObject and I pass in the string key1 in bracket notation, that basically says, go to the myObject object, look for the key1, and give me the value that corresponds to key1, which in this case is going to be value 1. Everyone good so far?
Yes.
Great. So why are objects useful? Well, objects are great because they actually let us capture a lot of information, yes, but the keys actually help us give us additional ways to kind of add extra context to the information that we're storing. So here we have an array, which is just a list of given values. And notice how here my array is called Pusheen, and it has 3 values: the string Pusheen, the number 7, and the string gray and tabby. I have all 3 pieces of information, but I'm actually not quite clear on what those pieces of information necessarily means, right? They're just values. And so whereas an array is a good place to hold a list of values I want to keep in a certain order, it doesn't actually contain any context for what those values represent. And so here's where an object really shines, because if I use the keys, if I store all these values in a Pusheen object but with keys, well, now what I can do is I still have all 3 values, but now corresponding to each value, I can associate a key with it. And so here between lines 10 and 14, I've created an object called Pusheen. There's 3 key value pairs. In the first key value pair, the key is the string name, and the value is Pusheen. Second one, the key is age, and the value is 7. And then lastly, for the last one, the key is color, and the value is gray and tabby. So what this means is now when I take a look at these 3 values, I have some kind of context for what they're representing or what the values mean. And so it's a really good way so objects are a really good way for us not just to store a lot of information, but be able to add some context around what that information represents or what it means. So creating an object is very straightforward. Like I said, we just use a curly brace. One thing to note is that the key of an object, all the keys have to be strings. Okay, all the keys of an object have to be strings, And so because they have to be strings, what JavaScript will actually do is whatever key you create in an object, JavaScript will forcibly convert it into a string on your behalf. Okay, JavaScript will say, you gave me a number. Great. I'm going to give you back the string version of that number. And so because of that, here we still see the same 3 key value pairs as on the previous slide, except now on the left-hand side of the colon, rather than having the string name, we just have name. And it's okay for us in this instance to do that. And the reason why is because the key has to be a string, whether or not we put the quotes around it is not necessary, because even if we don't put the quotes around the string name, JavaScript is going to convert it into a name for us. And so that's why this is one of the few instances where we can kind of get away with thinking that, well, because this is always going to be a string, I don't need to put the quotes around it. There's nothing wrong with putting the quotes around it. It's just kind of hilarious how lazy developers are. And sometimes they just say, I just don't want to type out the 2 extra apostrophes or quotes. And that's perfectly fine in this case. And then the other thing is kind of a repetition of what we just talked about, right? Which is, okay, we have our object. Now, how do I actually get the value out of the object? Well, I just do the same thing I did before, except now if I try to access any particular key, I still need to put a quote around it so I know I'm dealing with the string name, which will help me look for a key called name. One other thing to note is that if I try to access a key that's not in the object, I don't get an error, which for better or worse, I don't get an error. Instead, what I get is a value of undefined, which says, hey, this key, may or may not have a value in the object. But if this key doesn't exist right now, I'm not going to say this key doesn't exist. I'm just going to say, hey, the value associated with this key is currently undefined because it hasn't been created yet. And so the last thing we'll talk about is kind of putting both of these ideas together. I know we're throwing a lot at you all in one day, but like I said, we want to kind of make sure you get as much information as possible. Here, we're creating an object called GraceHopper, and we're setting it equal to this object. And on line 2, we have a key value pair where the key is first and then value is Grace. Line 3 and 4, same idea. We have a key associated with a value. On line 5, we have a key on the left-hand side of the colon sign, right? But on the right-hand side of the colon sign, aka the value, what we have instead is a function, the thing that we just talked about a few slides ago. And so this gets at 2 ideas. One, which is just simply that whereas the key of a function has to be a string, the value of a function can be any data type you want it to be. It can even be another object. So in that case, we call that a nested object. Okay, the value of an object can be any data type you want it to be. The key for it has to be a string. If you go back to our dictionary analogy, right, the word has to be we'll say alphabetical word in English if we're talking about an English dictionary. The definition associated with that word, it could be more words, it could be a picture, it could be a chart, it could be anything you want it to be, right? But the word has to be in English. Same idea here. The key has to be a string, the values can be anything. Secondly is here we can actually create a function as a value, and in this case we don't need to name the function because the function is already associated with the myMethod key. And when we run it, all it does is the console logs out I'm from a method. So one way for us to actually invoke this method is to actually invoke the key in the given object. On the last slide, one of the things we talked about was how to access a given or how to access a value is to use a bracket notation. Another way to access the value of a given object once you have the key is just to even be lazier and do object dot and then the actual value of the key. In this case, my method is a string, but I don't need to put quotes around my method because what the dot says is the dot is basically implying that whatever comes after it is going to be the name, is going to be the string value of the key. And so here, if I want to access the value associated with my method, I just do the object dot the key. So in this case, we do GraceHopper dot my method. Now, because my method is a function, remember what I said earlier, the only way to run a function in JavaScript is to use the open and close parentheses. And so here, if I actually want to run the myMethod function, all I got to do is do GraceHopper.myMethod with the open and close parentheses after it.
So can you kind of define the method again? Is a method just calling a function
Yeah, sorry,
in
that's a great
an
question.
object?
No, I should clarify that earlier. So this is a little bit of like a confusing, more like naming than anything practical. A method and a function are the same thing. They're both functions. The only difference between a method and a function is that a method is what we call a function that belongs to an object. Okay. I wouldn't stress too much about what we called it. We don't even have to use the word method. We can just call everything on this page a function. It wouldn't change the performance of anything we've talked about. But method and functions are both functions. The only reason why we call something a method is to denote that this particular function belongs to an object or belongs to a certain class. Okay, that's actually all I have for today. So only 7 slides, but clearly a lot of dense material here, right? Functions and objects are by no means cakewalks, and they're meant to be a little bit more involved. And so I know we threw a lot at you today, but are there any questions before we start on our workshops?